Hello guys, welcome you all for today's class. Today we are going to discuss about lift and drag. In our previous class we have discussed about boundary layer, turbulent and laminar boundary layer and the separation of flow. So this topic is also related with the boundary layer and boundary layer separation, because when flow takes place, suppose some body is moving, for example a car, you can see car is moving, and over the surface, you high speed car over the surface, you see that high speed air will pass over the surface of the car. Same thing take place when there is a cruising aeroplane, and over the wings and whole of the body. But we generally calculate wings area, because wings are both side wings of the air are responsible for creating drag and lift. So here we have to calculate what is a drag and lift acting on the plane, so that we can design it approximately. What is power required for engine to overcome this drag? What is power required engine to take a lift of the heavy load of the air. That's why this topic is very important. And when we take this example, how to first we discuss how to calculate lift and drag. We take example of the aeroplane wing. Take example of the aeroplane wing, and suppose this is a aeroplane wing. This is a aeroplane, not exact design, but this we can consider this is a aeroplane wing, and surrounding when it is moving with speed, with the cruising speed of the plane. So same speed, with same speed it will move. Take a surrounding air, surrounding atmosphere. This is a surrounding atmosphere, and take very small area dA. If it is small area dA, so surrounding stream of the air, if surrounding stream of the air will pass like this. This is a streamlined motion over the wing, because wings are aligned in such a way that it will be streamlined flow over the surface, so that the drag will be minimum, and stream will be also moving like this. These are streamlined motion around the surface, and the surrounding fluid will exert pressure from all sides. Surrounding fluid will exert pressure on this surface, and here also force pressure is acting at this place, that is a P pressure acting on this very small area dA. This area is not along the direction of the, neither in direction of the shear stress tau naught, or along the direction of the pressure force. So pressure force is acting, and shear force tau naught is acting over this surface. So let's take this area in bigger form. So take this area in bigger form here. We take this area. Let us take this area outside in big. This is a dA, and tau naught is acting along the direction. Tau naught is acting. So shear force equal tau naught into dA, and pressure is acting here. This is area dA, P into dA, and making this with horizontal angle is theta. So there will be vertical component. We can resolve tau naught, shear drag, drift drag, because due to shear stress, drag is acting along the surface of this small elemental area. So you can resolve here. This angle is theta. So let us say this angle is also theta. This angle is 90 minus theta, and this angle is theta. There are two components of the pressure drag, pressure force, P dA sin theta. Here PdA cos theta, and here tau naught dA cos theta. Here tau naught, this is vertical component, tau naught dA sin theta. So there are we can reduce this now, resolving vertical drag and vertical drag force and horizontal drag force. So DFD drag force acting. This is a drag force, means horizontally it is acting. So drag force equal tau naught dA cos theta, PdA sin theta plus tau naught dA cos theta. This is a drag force acting only on very small elemental area. So what is total drag? Total area is given A. So total drag force equal to FD, that is equal to, we integrate this small DFD for whole of the area, that is equal to PdA sin theta plus tau naught tau naught dA cos theta, indicating for a whole of the area. Similarly, we can find out lift force is acting on this small elemental area dFL equal to, now resolving all vertical component, that is a tau naught dA sin theta, tau naught dA sin theta, and minus, because this pressure force is acting downward, this component acting downward, so minus PDA cos theta. So total lift force equal to FL equal to integrating DFL or whole of the area, that is equal to integration of the tau naught dA sin theta and minus PDA cos theta. These are two equations for calculation of the lift and drag over any surface that is moving in the fluid. Fluid may be air or liquid. It may be air or liquid, but here we are considering mainly air, because we are considering calculation of drag force and lift force for aeroplane or car, motor car. But on the these are complex equations of calculation of lift and drag. To simplify these equations, on the basis of Buckingham-Pi theorem, dimensional analysis and simulation and experimental observation, we have simplified a general equation for lift and drag. So drag force Fd on the basis of simulation and modeling and experimental observation is equal to CD, drag coefficient, dimensionless number, into 1 by 2 rho V square into area, and FL equal to CL, drag coefficient, into 1 by 2 rho V square into A. Here rho is a density of the fluid, that is air. V is a cruising speed of the object. A is a frontal area of the wing, aeroplane wing, or frontal area of the car surface. If car is cruising forward, then frontal area of the car is whole top layer, top, over which it includes frontal area of the engine, bonnet, and roof. So this is a frontal area which we have to consider in calculation. These are two very simple equations. You can always remember this is a dynamic pressure. 1 by 2 rho V square, 1 by 2 rho V square is a dynamic pressure. Because of the motion of the plane, air will be very high speed glide over the surface. That is a dynamic pressure created by the moving air. And A is frontal area. CD is a drag coefficient, dimensionless number. CL is a lift coefficient, dimensionless number. FD is a force, drag force. FL is a lift force. So this equation, this topic become very interesting when you solve one question. So let us solve one question here. Question is a very interesting question. This is question: an Airbus Boeing 380 from London to Singapore, cruising at speed 1200 km per hour at altitude 40,000 feet, and temperature is given minus 40 degrees centigrade. Engine generate power 16,000 kilowatt. If 70% of the force is used, 70% of the power is used to overcome the drag, calculate lift and drag coefficient. And lift, total lift means what is the total load, that is including passenger load and luggage load, has to be taken up, because when a plane takes up, it has to bear whole of the load of the plane, passenger, including passenger, and this given is 50 kilonewton. 50,000 Newton force has to be lifted by the plane. So lift force is required. So this is a very interesting question, and almost atmospheric conditions are same, around 40,000 feet, and temperature is around minus 40 degrees centigrade. These are surrounding conditions, and here air density is given 1.12 kg per meter cube. So this question we have to solve. Here. So first, what are given conditions? What are given? Given cruising speed 1200 km per hour. We have to convert into meter per second. So let us calculate here. 1200 into 1000 into 3600, because in 1 hour there are 36 seconds. So you find here 3 and you get 333.3 meter per second. That is a cruising speed in meter per second. And power is given. Total power generated by engine is 16,000 kilowatt. Out of this power, 70% is used for the overcoming the drag, and rest of the power is used for some other purpose. For example, controlling mechanism, hydraulic mechanism, braking mechanism, communication. All electronic equipments are there in the cockpit, and air conditioning. So 70% drag power is required. So drag power, you have to calculate drag power. Drag power, you say PD, drag power equal to 15,000 into 0.7. This means 1,200. 11,200 kilowatt power is required to overcome the drag. So you know that we have to calculate drag force, because power equal to PD, drag force equal to drag power equal to drag force into cruising velocity, that is a V that we have calculated. So this is given 11,200 equal to FD into, this is kilowatt. We have to convert into multiply this, we have to multiply it because this is given in kilowatt. So 11,200 multiplied by 1,000 equal to FD into velocity 333.3. So calculate FD equal to 11,200 into 1,000 upon 333.3. So that is a drag force we have to calculate. So let us see, 11,200 into 1,000 divided by 333.3 equal to 3,603.4 Newton. This is an income in Newton. This is a drag force. Now very simple question become very simple for finding out drag coefficient. So let us take another sign. So FD equal to 1 by 2 CD into rho V square into A. So CD equal to 2 into FD upon rho V square into A. Now putting all values, 2 into 33,603.4 upon 1.12 into 333.3 square into frontal area. Frontal area, I think I have not dictated here, but frontal, this area is given in the question because wings area is always given in question. So wings area, let us take 40 meter square. Wings area means two sides, there are two wings, we have take this is 40 meter square. So take 40 here. I forget to mention the wing area or frontal area of the wings over which air will pass over the surface. So drag will create. This drag has to overcome. So now calculating what is your drag coefficient, that is equal to 0.0135. This coefficient is 0.0135 drag coefficient. So now CD equal to 0.0135 and total lift was given 60 kilonewton. Lift force FL is given here 60 kilonewton. In question FL is given because that load is given that has to be taken up by the plane. So let us calculate what is a lift power. Lift coefficient. For that we use equation FL equal to CL into 1 by 2 dynamic pressure rho V square into area of the wing. So CL equal to 2 into FL upon rho V square into A. So 2 into 50 kilonewton multiplied by 1000. So it becomes 50,000 Newton. 50,000 Newton into 1.12 into 333.3 square into area 40 meter square. This is equal to 0.024. So this is a very simple to find out. Once you understand what are lift force and drag force, it becomes very simple to calculate lift coefficient and drag coefficient. And most of the academic examination, you will find question to calculate lift and drag force or lift and drag coefficient of the aeroplane. Or sometimes you may be, drag, because in cars only you have to find out drag force. There is no any lift, practical lift is available in car, because if lift is available then car will move, car will fly. But when car will fly, it will become aeroplanes. That's why most of the time you will get to find out problem solving in calculating lift and drag coefficient for aeroplane. So this is very simple. Once you remember, this is a coefficient only, and dynamic pressure into area. Dynamic pressure into area multiplied by coefficient, that is the dimensionless number, equal to lift force, and drag force FD equal to CD, drag coefficient, into 1 by 2 dynamic pressure into frontal area. This equation becomes for finding out drag force. This is very simple, and I think there is no any doubt in your mind. If you still feel any doubt in mind, please mention your, I will repeat this topic again. And this is sufficient for finding out drag and lift coefficient or drag and lift force. So this is very important, because in competitive examination for Indian engineering service examination in mechanical engineering, certainly we get either a question in prelim examination or in mains examination. You get theoretical question for calculating lift and drag coefficient. Thank you very much for watching this lecture video. Please like and subscribe and comment. Thank you very much. Have a nice day.